So here we have our IC2 my instructor created, which is log equations without a calculator. So here our objective is to solve log equations without a calculator. The title gives it away. Okay, so our goal with this is just to solve for x. We're literally just going to plug on through and solve some equations, okay? And so our first problem here is log base 7 of x equals 2. So remember, any log equation that you have, you can always write it as an exponential equation. So that means I have 7 to the second power equals x, so 7 squared is 49. That one was pretty simple, straightforward. Looking at our second problem, we have log base 3 of 4x minus 1 equals 3. And so again, I'm going to write this as an exponential equation, which is 3 cubed equals 4x minus 1. So I'm going to have to do a little bit more legwork. 3 cubed is 27. That equals 4x minus 1. I add 1 to both sides to get 28. So therefore, 7 equals x. We're just going to fly right through these because we already know how to write logs as exponential equations. So that's really, really helpful. So I've got log base x of 9 equals 2. So that means x to the second power equals 9. I square root it. And in this case now, we will just take, normally when you take the square root of 9, you have positive 9 and negative 9. However, you'll see later on in pre-calculus having that negative log base and some of the issues that comes with it. So actually, we're just going to go with that positive 3, okay? Moving on to our fourth example. I have log base x, of 1/16 equals 2. So that means x to the second power equals 1/16. Take the square root, and a lot of us are like, oh my gosh, I can't do this without a calculator. Yes, you can. You can take the square root of 1, take the square root of 16. So I get x equals 1/4. Okay, so hopefully so far it's looking pretty good. Now, before we move on to our next problem, in the previous video we talked about the fact that that the natural log had a base of e, okay? One thing that I want to kind of revisit when I first was talking about logs, like if I had a log with a base of b, that would equal 1, because technically b to the first power equals b, right? And so I truly could replace log base b of b with 1. So ln, if I have ln of e, technically that ln's base is e. So ln e equals 1. Okay, because e to the first power will equal e. So like my base to my exponent equals my answer. Therefore, and you're going to see this a lot, anytime you see ln e, you're going to replace ln e with 1. That comes into play here in just a moment. Okay, so just to kind of give you some background with that, we again saw it in the previous day's video, but I just wanted to discuss why ln e equals 1. So looking at our fifth problem where we have ln e of the negative 3x equals 7. So we're going to have Lord have mercy, negative 3x ln e equals 7 because this is a power rule. So I need to move that exponent to the front. Remember that ln e equals 1, so I technically have negative 3x times 1 equals 7. So that's going to be negative 3x equals 7. And x is going to equal negative 7/3. Okay, so anytime, like I said, anytime you actually see ln e, remember that if a base isn't written, it's understood to be its actual base. So that an actual base of ln is e. The actual base of log is 10. Now those bases can change, but it's the understood base if nothing is written there. Okay, so let's move on to another problem, number 6. So I have log base 6 of 216 equals 4x minus 3. And so now what I see here is 6 to the 4x minus 3 equals 216. So what I'm going to really need to do is I'm going to need to get this in the form of 6. Basically because then if I can get the same bases, we're going to look at that. Okay? So I'm going to divide by 6, and what that goes in 36 times, and then I get 6 and 6. So now I have 6 to the 4x minus 3 equals 6 to the third power. Similarly to if I had 6 squared times 6 to the fifth, I could keep the base and add the exponents because that's the product rule. Well, what I'm going to do here is, because my bases are the same and it's set equal to each other, therefore the exponents are equal to each other. So I'm going to actually do 4x minus 3 equals 3. Okay, so I'm going to continue with that. So that's the reason why we needed to get 216 with a base of 6, because we needed those bases to match to be able to equal our exponents to each other. So then I get 4x equals 3 plus 3 is 6, so x equals 3 halves. So that finishes that one up. Moving on to number 7. Number 7, I have log base 4 of x squared plus 1. Oh, that was gross. X squared plus 1 equals 3. So that means I've got 4 to the third power equals x squared plus 1. 4 to the third power, 4 times 4 times 4 is 64, and that equals x squared plus 1. So then I'm going to subtract 1, and I get 63. That equals x squared. And I'm going to take the square root. Now, the one big thing is that we do need to take out any perfect squares. I know 9 can go into 63. So actually, my final answer will be 3 square root of 7. See how all of these things that we've learned in Algebra 2, everything just kind of intertwines, and we start to see all of these things in various problems. Moving on to number 8. I have log base 5 of x squared plus 4x plus 4 equals 2. So that means I'm going to have 5 to the second power equals x squared plus 4x plus 4. 5 squared is 25, so I have 25 equals x squared plus 4x plus 4. You guessed it, you're going to have to factor and solve. So I'm going to have to move everything over to one side. So I get x squared plus 4x minus 21. I'm going to do my x method to factor, and I get x plus 7 and x minus 3. So therefore, x is going to equal negative 7 and positive 3. So you can have more than one answer. That's okay to have. Moving on to number 9. Number 9, we have log base 2 of 16 to the x power equals negative 4. So that means I have 2 to the negative 4th power, and that equals 16 to the x power. Similarly to what we did in number 6, I need to get the same bases. So this 16 I know I can break up into 2's. 4 and 2, 2 and 2. So that means I have 2 to the negative 4th power equals 2 to the 4, and it's going to be 4x power because this x is here. So what I did here was I wrote the 16 as 2 to the 4th power, and that's raised to the x power. And 4 times x is 4x. So that's the reason why we have that 4x there and not just a 4, because the 16 was raised to the x power. So now I have the same bases, so I can set my exponents equal to each other. And when I divide both sides by 4, I get negative 1 to equal x. I just have one more problem for you, and then we are done with this. Only one video for this lesson. It's so exciting, mainly because I just plowed on through because we already know our exponent rules. So that's incredibly helpful. So I have log base 7 of 7x equals negative 1. So I have 7 to the negative 1st power equals 7 to the x power. Super easy. I already have the same bases, so I just set my exponents equal to each other, and there's no more solving to do. So that one, just wanting to end on a beautiful note. And this is the very last Gerwitz production that you will see this year. It's been real. It's been fun.